most of the relationship between the sets can be represented by the means of Venn diagrams. Since empty does not contain elements, the only answer or the only elements which you will get is A only. That is why it is called as law of identity or identity law. When I intersect odd natural number with natural number, the common elements are odd natural numbers only. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram. So in our previous session, we have learnt about the sets and the representation as well as the types of sets. Here in this session, we are studying about the operations on sets. That is, how we are going to perform certain mathematical operations between two sets. Now, before going to the operations on sets, we need to learn Venn diagrams. So, what do you mean by Venn diagram? The elements of a set can be represented inside a diagram called Venn diagram. And since this was given by a mathematician, John Venn, this name was given to the diagram. So, how will be the Venn diagram? So, most of the relationship between the sets can be represented by the means of Venn diagrams. Here, universal set is always represented by a rectangle and all the other subsets are represented using circle. So, you have already learnt what is universal set because universal set will be the major set for other sets. That's why we will represent universal set with the rectangle and other subsets inside the circles. So, let's take an example here. Let U is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the universal set for which A 1, 3, 5, 7, 9 is a subset. I told you A is a subset of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is, A is a subset of U. That's why I will represent the elements of A inside the circle. All the subsets should be represented inside the circle and the elements of A should be written inside the A. The elements which are not in A is written outside the circle or inside the rectangle. So, overall when I consider this complete rectangle contains all the numbers here, but this circle contains only the elements of A. So, this is how we will divide the subset from the universal set. Now, let's see the mathematical operations on set. The very first one is union of set. So, what is this union of set? Let us take two sets A and B. Then, the union of the set A and B is nothing but all the elements of A and all the elements of B. So, that is A union B means if X belongs to A or X belongs to B, you need to write it all the elements inside A or elements inside B. Suppose when I take set A is equal to minus 1, 0, 1 and set B is equal to 1, 2, 3, 4. Then A union B is nothing but writing all the elements in A or B, whether it is in A or whether it is in B, pull it and write it in A union B, that is minus 1, 0, 1, 2, 3, 4. So, this is how we will write A union B. So, that is or means in any one of the set, if the element is present, take it and write it in the set A union B. So, this is the union of sets. Let's take an example. Let A is equal to 2, 4, 6, 8, 6, 8, 10, 12, set B. Find A union B. How we can write A union B here? A union B can be written as 2, 4, 6, 8, 10, 12. So, therefore, you should write all the elements either in A or in B inside the set A union B. Note here, union of set and its subset B is the set A itself. When I say any set is a subset of A, that means B contain all the elements of A. So, therefore, the union of A union B will be A again. For example, when I take 1, 2, let me take it is a B and set A as 1, 2, 3. Since 1, 2 is also in A, so here B is a subset of A, and when I make A union B, clearly A union B means writing the elements inside A as well as B. that is 1, 2, 3 only. But what is 1, 2, 3? 1, 2, 3 is nothing but A. So therefore, when any set is a subset of A, then A union B will be A, only when B is a subset of A. Now, the union of the two sets can be represented by a Venn diagram as shown in the figure here. That means A union B, here it means you need to write all the elements in A as well as B. So that is why we will combine these two circles and we will shade these two circles completely. So this is a universal set. A and B are the subsets. So therefore A union B is all the elements inside A as well as B. Let A is equal to AE IOU, B is equal to AIU, show that A union B is equal to A. So when this is possible, only when B is a subset of A here. So clearly you observe AIU is in A. Okay, so clearly here B is a subset of A. So therefore we can write A union B is equal to A. No need to verify and write it. By the observation only we can clearly see set B is a subset of set A. So therefore if you make the union, you will get back the set A only, that is AEIOU. Some properties of the operations on union. So you have studied many laws whenever you are learning the number system: commutative law, associative law, identity law, inverse law, and many. So the same thing or the same laws can be applied for the operation on sets also. For union of any two sets, A union B is same as B union A. See here, in the previous example, A union B means it is A. What about B union A? B union means writing all the elements in B as well as A. That is also same. So therefore, it satisfies the commutative law. Also, taking any three sets and taking the union of all the three sets, it satisfies the associative law. Next, A union empty set. If you are taking the union with empty set, since empty does not contain elements, the only answer or the only elements which you will get is A only. That is why it is called as law of identity or identity law. So therefore, empty set is the identity of U. Next, when you take a union of the same set, you will again get the same set. That is why you will call it as an idempotent law. And when you take universal set with A as a union, the major set, that means you need to write all the elements in the universal set as A only. But clearly we know that A is a subset of U. Whenever A is a subset of U, the answer which you will get when you make a union with the set U, it is U only. As we know that whenever B is a subset of A, B union A or A union B will result in A only. Since universal set contain all the elements and A is a subset of U here, the union of these two sets will be universal again. We will move on to the intersection of set. So what do you mean by intersection of set? Clearly, consider two sets A and B here. So intersection of two set is nothing but writing the common elements which is in A as well as B. So it should contain both in A and B. So it is denoted by this symbol and we will define as it is a collection of all elements where X belongs to A and X belongs to B. When I say OR here, it is nothing but union. If the element is present in any one of the set and we are writing it in the form of A union B, it is a union of set. But if any element is present in both the sets, then we should write it in the form of an intersection of set. So therefore, let us take an example here. Let A is equal to 2, 4, 6, 8 and B is equal to 6, 8, 10, 12. Find A intersection B. I said intersection is nothing but writing the common elements in both A and B or the elements which is in both A as well as B. So therefore, A intersection B is only 6 and 8. Because 6 and 8 are the common elements which are in A as well as B. Let A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and B is equal to 2, 3, 5, 7. Find A intersection B and show that A intersection B is a B. Now see here, let's take A intersection B. Again, A intersection B is nothing but writing the common elements in A and B. What are the common elements which we have inside both sets? That is 2, 3, 5, 7. But clearly you can see A intersection B is the set B itself. So why? Because we can see that B is a subset of A. So whenever B is a subset of A, remember A union B is always A, the major set, and A intersection B will always be the minor set, that is B. So clearly you can see the thing is proved here. Intersection of sets A and its subset B is the set B. So I have showed previously with an example. So if any set is a subset of A, then their intersection will be the minor set. So if B is a subset of A, then A intersection B is B only. The intersection of two sets can be represented by a Venn diagram using this symbol. So we have a rectangle here and two sets A and B. The common element has to be written inside this oval only. So when I represent the operation intersection, this is how I should shade the region. So when I shade entirely A and B, it represents A union B. When I shade only this part, that's this oval part here, that means the elements inside A and B have to be written inside this and it has to be shaded to represent the operation intersection. Disjoint sets. If A and B are two sets such that A intersection B is equal to empty, when A and B are called as disjoint set. So this is very important. So when you are taking any intersection, if there are no common elements inside the set, then the set is empty. Whenever the intersection of set is empty, we call them as a disjointed. So therefore, let me take an example. Let me take set A is equal to 2, 3, 4, 5, 6 and set B is equal to -1 and 0. Now, do you find any common elements? No, we can't find any common elements which is in A as well as B. So, therefore, clearly A intersection B is empty here. So, therefore, here we call A and B as disjoint sets. Now, as in the case of union, intersection also satisfy some of the properties. That is, it satisfies commutative law, associative law, and whenever you intersect any empty set, the result will be empty. Whenever you intersect with universal set, the result is A. Why? Because A is a subset of U. When you are intersecting any minor set with the major set, the result will be the minor one. But empty set means there is no elements. If there are no elements which is common with A, obviously we will get an empty set only. So this is called as law of empty and law of universal. Next, idempotent law. When you are intersecting the same set with itself, you will get the same set. Next, we have a distributive law, that is A intersection B union C can be written as A intersection B union A intersection C. We call this as intersection distributes over union. This can be verified by taking examples. Next question, find the union and intersection of the following pairs of set. So here one pair is given, we need to find the intersection as well as union of the set. The first says X is a collection of all natural number and multiples of 3. When I say a natural number and multiples of 3, then set A will start from 3, 6, 9, etc. and it goes on. It goes until infinity. Set B is a natural number less than 6. Then B is a natural number less than 6 means we have 1, 2, 3, 4, 5. Now we need to make the union of these two sets. When I make the union of these two sets, we need to write all the elements inside the set. That is 1, 2, 3, 4, 5, 6. Next there will be only the multiples of 3. So intersection, A intersection B means I need to write only the common elements. The only element which is common in both is 3. So therefore here it is 3. Next pair, we have A as 1, 2, 3, B as an empty. So A union B means we need to write 1, 2, 3 union empty set. We don't have any element to write inside the set. So therefore it is 1, 2, 3. So we can write here A union B is again A. What about A intersection B? A intersection B will be B or empty again. Because when you intersect any set with an empty set, the result is empty. And we know that B is a subset of A. Therefore, we can write A intersection B as B or A intersection B as empty. Next, let A is equal to AB and B is equal to ABC. Is A is a subset of B? What is A union B? Clearly, you can see here element AB are in set B. So, therefore, we can write A is a subset of B. Therefore, I can write A union B as B. Because B is the major set here, and when I take the union of these two sets, I will get back ABC again, which is set B. So next we have the four sets given A, B, C and D. So we need to find out A union B, B union D, A intersection B union C, B union C union D. The very first one we are taking the union of A and B. So that's why we need to write all the elements, that is 1, 2, 3, 4, 5, 6. So this is our A union B. Next I need to take B union D. So B union D is 3, 4, 5, 6, 7, 8, 9, 10. Next here I have A intersection B union C. So first either I should perform A intersection B first or I need to perform B union C first. So therefore let's take the third one, A intersection B union C. First let me perform what is B union C. So when I say B union C, it is 3, 4, 5, 6, 7, 8. So this is our B union C. Now I need to intersect with this with A. So I am intersecting A now. Intersecting with A means 1, 2, 3, 4. So what are the common elements in this sets now? So only 3 and 4. So therefore this gives you the set A intersection B union C. Next we have B union C union D, that is we need to write all the elements of B, C as well as D. So B union C union D is nothing but 3, 4, 5, 6, 7, 8, 9, 10. So this will give you the union of the set B, C and D. Next, if A is a set of natural number, B is set of even natural number, C is set of odd natural number, D is prime number, we need to find the following given. So now here clearly you see when I say A is a natural number, obviously it has all the numbers until infinite. So next we have B, it is only the set of even numbers, so therefore it has only even numbers until infinity. And C has only the odd natural numbers, that is 1, 3, 5 until infinity. And D is only the prime number, so therefore set D has 2, 3, 5, 7, 11, etc. Only prime number. And clearly you can see B is a subset of A, C is a subset of A, D is also subset of A. Because all of them are subsets of natural number. Now let's try the intersection of the following. A intersection B. B is set of even natural number and with natural number. We know that B is a subset of A, so therefore B is the answer. A intersection C means C is a subset of A, so therefore C is the answer. Because when I intersect odd natural number with natural number, the common elements are odd natural numbers only. So that's why we will get C. Prime number intersecting with natural number is again prime numbers. Now we will take B intersection C. B is only even numbers, C is only odd number. There are no elements or no numbers which are in common. So therefore, this is an empty set. Now B intersecting with D. Observe B, it's completely even natural number. D is a set of prime number, but there is only one even number. So therefore, B intersection D is 2. Next we have C intersection D. C is set of all odd natural numbers, but D is a set of prime numbers which include 2 and only odd prime numbers. So therefore, the only common elements here you can write as odd prime numbers. You can't take other odd numbers because they are not prime. Which of the following pairs of sets are disjoint? So disjoint means their intersection must be empty. The first one, 1, 2, 3, 4. X is a natural number which lies from 4 to 6. So the only elements are 4, 5, 6. So these are the elements in the second set. Clearly, we have, when you do the intersection for these two sets, we will get 4. So therefore, this is not disjoint. So not disjoint. Next one we have A, E, I, O, U, C, D, E, F. We have element E as a common element. So therefore, this is also not disjoint. Next we have X is an even integer, X is an odd integer. Even integer and odd integer so are not one and the same. So therefore, it is a disjoint set. So these are an example for disjoint sets. So I hope you understood what is union and intersections of the two sets. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.